Welcome back to Mrs. Ogram's Maths. We are continuing our theme of doing vectors questions, and this is the one from the summer 2019 question paper 33 for the P3 exam. So part one is we want to find the distance from a point to the line we've been given. So this is what it looks like. We've got the line with 1, 2, 3 plus mu 2 minus 1 minus 2. We've got a point P somewhere, which is 4, 2, and minus 3, and we're trying to work out the distance from P to the line on a perpendicular. So we can first of all label that point where it touches the line there, and I'm going to give it an N. There is a video on how to do this. If you can't remember, just go back and look at my channel page and you'll be able to find it under the A2 vectors stuff. Okay, so ultimately what we're aiming for is to be able to work out the length of NP. First of all, we need to work out NP itself. Now NP will be OP minus ON. So we need to work out ON. So ON will be somewhere along that line which we've got here. Now it happens at one particular instance of mu. We don't know what that is. I'm going to call it t. So we're saying it's not the variable mu, but it's one particular instance of it. So we can summarize that as 1 plus 2t, 2 minus t, and 3 minus 2t. So then NP will be to go from N to P, doing the OP minus ON. So OP, that was 4, 2 minus 3, and take away what we just worked out as ON. Okay, and simplify that down. Then the next bit of information we are going to use is that NP is perpendicular to the line, so the scalar product of NP and the direction vector of the line will be 0. So we've got the direction of the line is 2 minus 1 minus 2. If we do the scalar product with what we just worked out for NP, then the answer to that has to come to 0 because they are perpendicular. We can use that to work out what t is. Working that through gives us that t is 2. So now if we pop that back into NP, we'll get, so putting 2 into each of those places for t, minus 1, 2, minus 2. So then the modulus of NP comes to 3. So that's our final answer for part 1. Then part 2 is that we've got the equation of this line L sits on a plane with this equation here, and we need to work out what A and B are. So I'm just going to transfer that down here. So we are looking something like this. So we've got the plane. Now the equation of the plane is as follows. Equation of the line sitting entirely on the plane. So the first thing we can do is, if this line always sits on the plane, then it will always satisfy this equation. So we can put in the lines for x, y, and z into that equation. So we would get this happening. Any value of mu in that we want, and that will still hold true. So we can do that with a couple of them and then use that for simultaneous equations. Mu is 0, this is what we get. By mu is 1, we will get another another equation that we can use. Simultaneous equations to work out A and B. So I'm going to times that first one by 3. And then do a subtraction. So we've got A is 3 and B is 2. Just double check we didn't need anything else from the question. Okay, there we go. A and B.